skills. It's Meshari almutairi for Kuwait, who will present on strategies for oil-contaminated sand in Kuwait. So the floor is yours.
Hello everyone. Actually, I would like to appreciate the coordinator to give me this opportunity to present my project, which is the evaluation of multi-stage strategy for the Kuwaiti oil lake. Before to jump, I would like to introduce myself. Actually, I just got my PhD before 1 year ago, and the thesis of my the topic of my thesis was the remediation strategy for the Kuwaiti oil lake. I spent 4 years at that time. Today, I am going to present for you the story of challenge for the Kuwaiti oil lake and how we can treat this contamination. So, actually, the topic of the presentation today is evaluation of multi-stage strategy for remediation of Kuwaiti oil lake, which has done by me, and the efficiency of this method has been evaluated by the Kuwait National Petroleum Company, who they are in charge for the remediation of contaminated soil, of oil-contaminated soil. Actually, during this presentation, we're going to highlight on the case study, the technology development status, the field pilot test, the memorandum of understanding, scope of the pilot, result of the pilot, commercial consideration, and using the treated sand in engineering application. Unfortunately, I will tell you today a sad story, which is the Kuwaiti oil lake. Kuwait environment suffered significant damage resulting from Iraq invasion in 1990. And the result of this destruction, huge quantities of crude oil had released, forming what are known as the Kuwaiti oil lake. The Kuwaiti oil lake now are drained, and this contamination or this oil lake causes a threat to the human and to the ecological system. So this oil lake now reach to the groundwater table. That's one of the oil lake. If you see here, we have the oil sludge and the oil contaminated sand. My project, I'm focusing on the oil contaminated sand itself. If you see here, we have the oil sludge and the oil contaminated sand. Now, the Kuwait Oil Company, who they are involved for the remediation of Kuwaiti oil lake, they are set up the oil sludge for recycle, but they are facing with the problem, which is the oil contaminated sand. Actually, we cannot say like we have oil contaminated sand, because the oil has been withered for 25 years now. So the characteristic of the oil now is changed. Okay, it's not crude oil anymore, because all the volatile has been evaporated already. So we are dealing with a withered contamination, high H14 compound. So there is some work has been done in Kuwait before. But before we go, before we go further about what the work had done before, I would like to explain the number of oil lake which we have right now. We have around 172 near from the fresh groundwater. So the north oil, in the north of Kuwait, we have only one source of fresh groundwater, which has been affected now by polyaromatic hydrocarbon, since there is leaching happening. And we have around 200 oil lake, which is in the middle of the biggest oil field in the world. We call it Budurgan oil field. And earlier studies, they recommended to treat this contamination, because right now the source of oil lake, it's become as a source of PAH, which is the polyaromatic hydrocarbon, which considered as a carcinogenic compound, which could be affected the human being and even can be reached to the groundwater, which reached it already. The work had been done in Kuwait since 1990. In 1993, that's the first work which had been done in Kuwait. They used a bioremediation. Okay, bioremediation can be succeed at that time, since you are using bioremediation and the contamination that contamination was fresh at that time, the bioremediation can be succeed because still you will have the light contamination. But right now, the bioremediation cannot be succeed anymore because you are dealing, as I told you before, you are dealing with the weather contamination. That's why you need a new technique. As I explained, I spent 4 years of my life trying to find the best way to treat this contamination. When I studied my PhD, I got different scope about which the best method to treat this disaster. Based on the 2 different comparison studies, I found that we have around 166 soil remediation, which applicable for oil field. But which one of them I should choose? Based on the DISC study and another study we call it House of Equality, both of them, they suggested to me soil washing. But even the soil washing, we are talking about something common. Soil washing, you need some specific technique. That's the thing. I spent, as I told you, 4 years trying to enhance the soil washing technique. And after 4 years, I found the best method for the soil washing technique. I will explain it now. Before I go for the soil washing itself, that's the technology development. When I started in 2010, I started with bioremediation, and I found that the bioremediation faced, the microorganisms, especially the rhodococcus, faced a big issue regarding for the biodegradation for oil contaminated sand. Then, based on the literature, I recommended or I suggested to use the soil washing. In the soil washing had been developed from the lab to the pilot. In 2014, I scaled up the machine. The machine now is patented. Patented in US, in Europe, and in Kuwait as well. That's the machine, which is the soil washing machine. Actually, the good thing, this machine, I'm using only water, no surfactant, no chemical, only water. Only water to treat the oil contaminated sand. Based on the scientist mentioned that like dissolve the like. So for example, if you are dealing with oil contamination, you need like a solvent or chemical to dissolve it or to extract it. But this machine, it's act as a solvent because it's increased the repulsive force, increase the negative charge. When the negative charge increase in the machine, it's allowed the oil to be separated easily without any surfactant. And this machine, as I told you, this is soil washing, then it makes sense. When you wash something, you will have 2 things. You will have treated sand, okay, we solved the problem, but we created another problem, which is the oily wastewater, which had been created from the soil washing technique. Even the soil washing technique had been treated as well, and the oily sludge had been separated alone for recycled. After I graduated from University of Portsmouth, I was searching for another company, to joint venture with them to apply this machine. I went to all the companies. Around 52 companies came to Kuwait to try to treat this contamination because the Kuwait received 3 billion from the United Nations to treat this disaster. All the 52 companies, no one of them achieved the target. The target means they should lower the level of the total petroleum hydrocarbon TBH below 1%. No one of the companies during the pilot or during the last 5 years achieved this results. All the companies, because actually it makes sense, because all of them, they are using the bioremediation, and the bioremediation is difficult for them. It's difficult for them to face the issue of the higher contamination, which is more than 50,000 ppm. I signed MOU with Kuwait National Petroleum Company to test the efficiency of this method. If you see that the the pilot. I'm gonna explain it now. We have, like, if you see the picture, I don't know if you will see it on the left side. The first spot, which is the soil washing machine, then I have the sand separator and the treatment of the oily wastewater. And the scope of the pilot, because the problem is, there is around, as I told you, 52 companies, they came and tried to treat this contamination. Okay, how I can deliver this information, I can tell them, okay, hold on guys, we have another method here, which has been developed. It can do the job, but without the evidence, without the efficiency, I cannot prove them. That's why when I signed the MOU with the KNDC, they give me this opportunity to announce to the other companies that's one of the solutions. If you see here, we have pre-treatment, soil washing system, sand separator, water treatment, oil residue. The first one, which is the soil washing system, and the second is the sand separator and the treatment of the water. And one of the main aim of this process, to make it zero waste. What means of this zero waste? Because it makes sense. We have a contamination. Contamination exists in the sand. I separate it from the sand to the water. Then it's removed from the water, become alone. This one, it's become a hazard. But it has kind of asphaltene. That's why I use it for road construction right now to enhance the capabilities of the road in my country. If you see this schematic, first of all, I had done seeding. You know, because at that time, when I signed the MOU with the KNDC, they brought for me 3 different samples of oil contaminated sand. They brought high contamination, medium contamination, and light contamination to test the efficiency. Actually, the sand, when they brought it in the side, you know, it was a district of the war. So you can expect everything is going to be mixed with the sand. That's why I had done the sieving in the beginning. You know, sometimes I found like shoes or plastic and wood, you know, because it was the side of the war. That's, you can expect something going to be mixed with the sand itself. So in the beginning, I had done sieving analysis to separate what the mass we have. Then the sand is shipped to the SWS, which is number 3, by solid pump, which is the soil washing machine. Then the oily wastewater and the treated sand sent to number 4, which is the sand separator system. I allow this machine I allow the sand to be settled around half an hour because, as I told you, just a pilot, and I can enhance the separator process by using hydrocyclone. It's make it more faster. But right now I'm using only general sand separator system. And then the oily wastewater has been sucked up to the flocculation tank, and the sand will be shifted, or the treated sand shifted from the top and from the bottom as well. The oily wastewater, I'm using a new system, which is not a new system, it has been applied before, but I'm reduce the concentration or the dose of the coagulant. I'm using alum to neutralize the oil residue, which is immiscible with the water, and allow it to be neutralized, and then the oil sludge will be settled down, and we have a treated or clean water. The treated water will be recycled again, and the oil sludge has been shifted for further use. Actually, that's the concentration of the sand which had been brought to the side. If you see in the picture on the left side, okay, we have before and after. Before gonna be the one in the front, and after, which is the one in the back. The first one was the high contamination. I don't know if it's clear to see it. Is it black? And the one in the middle is the medium, and the one on the right is the light contamination. That's the type of contamination. It was the concentration of light contaminated sample was 8,000, and for the heavy was 18 and 11. Actually, it's not consequence because they brought it the first week heavy and medium, light, medium, and heavy. Let's talk now about the project itself. As I told you, the ones that I had done, it's only pilot. So the machine can be washed around 150 kilogram of the sand within 2 hours for the high contamination and 1 hour for light contamination. Then the sand separator system will take only half an hour to separate it. And then the oily, the concentration of the alum, as I told you, alum is kind of coagulant. It's allowed to neutralize the oily in the water and allow it to be settled down. And then the water will be recycled. And this amount of oil residue, which had been separated from the total water had been used. For example, I used 200 liters of water for washing the oil-contaminated sand. The much amount of oily sludge which had been separated for the light is around 30 liters. For heavy, 64, that's the average. And the medium is around 45. Finally, I got a proof from Kuwait National Petroleum Company for my methods and for the technique itself from A to Z. If you see here the contamination before and after, I reached it below 1,000. We had a Kiva limit. Kiva means Kuwait National Protection Agency. They mentioned that the cleanup level should be below 10,000. I reached it below 1,000. If you see here, 900, then for the heavy, it's around 3,000, and the medium below 1,000 as well. Commercial concentration. Of course, when I had done this one, there is planning. The plan is to scale it up. I got the proposal for scaling up, and now I'm just communicate to build it up. The machine, it can wash 25 tons per 1 hour. Even the cost of the machine, we can say it like is much cheaper than the other machine. And the efficiency, you had seen it now. And the good things, there is no chemical, environmental friendly sounds, no chemical, no surfactant use, only water, only water. I know for scientists, it's act as a miracle because the water cannot do the job. Because based on science, like dissolve the life. But believe me guys, it do the job. Because we increase the repulsive force. Because there is polarity in the water. There is a negative charge in the water as well. I use the negative charge in the water. I use the negative charge in the water to allow the water to increase the repulsive force and allow the oil to be separated exactly like the salt will do. If you see here, that's the commercial, which is 25 ton, and about the efficiency for the commercial one will be similar or it's gonna be much better because the pilot that I have done by my own and the commercial will be remark all the mistakes that have been done for the pilot. So the result will be much similar or better as well. Yeah, 2 minutes, okay. For the treated sand, I'm using now the treated sand for commercial or for, I mean when I say commercial, for coastal project, because we have a lot, in my country we have a lot of coastal projects in the beach. This kind of sand, it's allowed to penetrate, it's prevent to penetrate the chloride inside the concrete. It's act as a waterproof. When I had done a water absorption test, the water absorption test sent us a message and tell us that the penetration is reduced from 3% to 0.5%. So even the water absorption test and the durability is enhanced by using this kind of sand. Conclusion: this project is cost-effective project. All sand fraction can be treated, water treatment as well, meeting the KIPA standard. There is no any emission or discharge from the system. Thank you so much. and I appreciate your attention.
Thanks. So before going to the last presentation, still the floor open for questions. Yeah, to the back.
Thank you very much for this miracle-like something story. I was just wondering, would you have any estimates or calculations on the cost per kilogram of soil?
Yes.
Do I have to be also then disclosed, or what is the average cost?
$50 per 1 meter cube
Of water, of soil?
of soil. For all the treatment,
$50.
$50 per 1 meter cube.
Is there any second question? So just to, then it again, okay, and the other Austrian, perfect.
Again, do you have an idea why the 50 companies failed? What were the problems there? Are the parameters, it's too dry, or the lack of bioremediating, stimulating?
Yes, because as I told you, because we are not dealing with the crude oil anymore. You know, the bioremediation can be succeed if you're dealing with the crude oil, okay? But you don't have crude oil anymore. The characteristic of the oil now is changed. You have a withered oil. All the volatile is evaporated for 25 years. So you have only asphaltene and resins, which is long chain of polyaromatic hydrocarbon.
Thanks, clarified. So finally, thanks again for coming to this conference and
Thanks.
presenting on Kuwait. So I'm calling for Fernando de Pena Ribeiro. So this is, we are leaving now the big business of